What's up guys? In this video, I'm going to be driving around a prototype version of my Rover for the first time. In the last video, I set up dual motor control using an Arduino in my computer. Now, a big issue with that is that for it to work, the Arduino had to be plugged in directly to my computer, which doesn't make it very useful for driving around. It would be a lot more helpful if there was an onboard computer that the Arduino could connect to and get commands from there. But having an onboard computer poses another issue. How do we get the commands from my computer onto that computer for it to send over to the Arduinos? Well, that's the kind of problem that can be solved using ROS2 topics. I explained ROS2 topics in my video about simulating a rover. So I'm not going to explain exactly how they work, just know that topics are a way to allow multiple computers to send messages to and from each other. In that video, I actually used a specific ROS2 node called teleop_twist keyboard. Now, I'm going to actually use this exact same node to control my real rover. So now that we have this node open, we'll see that it allows us to increase and decrease the speed of it, and I can actually hit keys on my keyboard to control the output. If we type in ROS2 topic list into another terminal, we can see the list of all the topics being used by ROS right now. The one we're interested in is this one, command velocity. Now, if we do ROS2 topic echo / command velocity, and we hit something here, we'll see exactly what's going on behind the scenes. So when I type different keys on my keyboard, they're actually generating different outputs that are being published to the command velocity topic. If you notice, the only two values being changed are linear x and angular z. We can also run ROS2 topic info on the command velocity topic to see exactly what data type the information is. So we can see the type is geometry messages / message / twist. Using this information from the terminal, we now know that we need to read twist messages from the command velocity topic and isolate the linear x and the angular z values from the topic. So I'm going to give a quick overview of the node that I wrote to control the motors. So here we're making a Python class called motor controller, and we're just initializing it and creating a subscriber in ROS. Now this subscriber is subscribing to the command velocity topic and it's reading twist commands. Now how a subscription works in ROS is whenever the subscriber receives a message from that topic, it'll call whatever function you put here when you create it. I'm calling the twist callback function. In this function, we're taking in the twist data and we're grabbing the x and the z values. Now over here, I have this big old set of if statements, which is basically creating the command for the Arduino. So if there's a z value, then it means we're turning and we're going to send a d or an a. And if there's an x value, then we're going to send a w or an s because it's moving forward or backwards. Then at the end, I create a message where I just put in the direction and the rounds per minute, and I send that over to the Arduino via serial USB. Now at the very start of the program, we're initializing serial port 0 and serial port 1, which are our two Arduinos. So over here at the bottom of the twist callback function, that's where we're sending the messages to. So the flow of everything goes like this. From our computer, using the teleop_twist keyboard, we're publishing messages to the command velocity topic. Then this motor controller node is subscribed to that topic, and it's reading the twist commands from there, grabbing the linear x and the angular z values, and converting that into a message for the Arduino to read. It then sends those messages to the Arduinos via serial USB. So once I had that node, I uploaded it to my Raspberry Pi and I tested it, and it's actually able to function completely independently of my computer. So I plugged my Raspberry Pi into both Arduinos and I taped the motors onto the sides. So it's a little like weak. It's held on like very like loosely. So this is an extreme, like this is for sure just a prototype. But I'm going to quickly fix up the wheels and make sure they're all like secure, and then I'm gonna test it out. Okay, so I'm gonna hit the on switch and we should see that LED light up. The rest of the LEDs come on. We should see on the bottom the green LEDs from the motors are on, which is all very good. So this means that all the connections, all the jumpers are all like secure. And so we don't actually get any visual from our Arduino because it's not plugged in. But what we can do is from my computer, so I can actually connect to the robot to the Raspberry Pi via Wi-Fi. And so now we'll see that we're actually inside the terminal of the rover. I just ran a couple commands that'll set up the ROS packages so that they're ready to be run. And in this terminal, I'm running the teleop_twist keyboard, which I use. This is the same program I used to control my simulated rover, and now I can use this exact same program to control the real one. So over here, I'm gonna run my motor controller node, which I wrote earlier. So we'll see it say serial 0 okay, and then serial 1 okay. And then it'll say the node started up. And so now, it should be very noticeable when this starts moving. There we go. And now I can stop it. And now we can go the opposite direction. Perfect. Stop it. We can rotate. So this set of wheels goes this way. This set of wheels comes this way. Perfect. And now the other direction. Beautiful. So now I'm gonna take this and I'm gonna put it on the ground. We're gonna see it move. So we're gonna go forward Oh, that's the wrong way. The front of the robot's facing this way. I'm actually gonna flip it around. Even though I could just have it go backwards, but I want it to be more intuitive for me as I'm controlling it. So forwards. And so you can see the wheels are like a little like, there you can see the weight of it is like pushing these wheels down. And so they're bending out of place. And that's just because I'm taping them on. Let's see if it can come back. Good. Stop. Okay. Let's move it forward a little bit. And now let's try and rotate it. That's what I thought. So it really struggles right now with rotation. And I think that's mainly because some of the wheels, like the wheels are just not secure enough right now. Like that's the main issue. They're not secure and not all of them are touching the ground at the same height. Oh, but you can see it trying, right? Oh, okay. Okay, we're getting a little rotation in place. But it's like, it's really struggling with that. And that's mainly just because if you look, it's like hitting into the body of it all. And so like, it's not able to, it just keeps running into itself, right? The wheels, because they're just not secure. And that's literally just because of the way this is like a very, very fast prototype. Like I spent a day in the garage, like putting this all into a cardboard box. So, but it can go forward and backwards like fine. Like this is forward, and then we'll stop it before it goes off, and then we'll go backwards. And then I should be able to slow it down. There we go. See, it slowed down. Oh, let's see if it can actually come back up the ledge. It's a very small ledge, but it can, okay. I'm gonna actually have it go down. And I wanna see it come back up. Stop. Now let's go back. There we go. Okay, so this is like, you know what? For like a first prototype, like this is pretty good. Like I like this. Let me stop it. Just keep going and keep going. But yeah, and then if I want to turn it off, all I really have to do is back here in the terminal. I just turn off the node, run the sudo shutdown -h now, and this is just gonna shut down the Raspberry Pi. Put in the password, boom. So in a second we'll see the connection closed, and if we come back here, we should see all the LEDs, most of them shut off in a second. There we go. So these LEDs came off. At the bottom, we'll see that the motor LEDs are also off. This single LED is on though, because that's just the raw power. So if I turn it off now, it's off, everything's fine. And yeah, so there it is. That's the first demo of the first prototype of my Rover. I can't believe I actually got it to drive around my garage. I mean, this is just, I can like hold this in my hand. Like this is kind of awesome. So obviously, it's very clear that I need a much more stable chassis, and I actually need to secure everything in place a lot better than it is right now. I was not envisioning a cardboard box as the final product, so I'm definitely gonna work on a chassis which can properly hold all these parts like safely and not have all the wires like scrunching up against each other, just because it seems a little unsafe, and some of the jumpers might come out, and that would kind of screw over the programming if a cable just pops out in the middle of driving. But yeah, thanks so much for watching. Hopefully you enjoyed this this milestone, and I'll see you guys in the next video.